Hello, hello, my geometry gems. We are going to do, today we're going to talk about central and inscribed angles within circles. And this is going to be your quarter 3 extra credit assignment. The great part about this is it's going to help you tremendously when you guys go to do your spring break challenge, because like the first couple of questions I'll talk about circles, which I know we haven't covered yet, but we're going to cover now and should be like incredibly helpful for you. So let's get ourselves started. So my notes here say a central angle is an angle with its vertex at the center of the circle. So it's right at the center here. And the two sides are something called they're both radiuses, right? But we don't say radiuses, we say radii. That's just the plural of it. So there's more than one. So it's radii, R-A-D-A-I-I. Oh, there's no A. Whoops, sorry. It's just I. Radii. So that means more than one radius. And remember, radius is it's from the edge of the circle to the center, right? The sum of all central angles in a circle is 360 degrees, right? And we already know that a circle is 360 degrees. So in this picture here, this E is the center of my circle. The 84, right, is this side's a radius from A to B, and this side's a radius from C to B. So this is an angle that's in the center. So this angle right here is 84 degrees. So an example of a central angle is angle ABC. The degree of the arc formed by the endpoints of the central angle is equal to the degree of the central angle. So here's my angle right here at the center is 84 degrees. Now this piece called the degree of the arc is like part of the circumference, part of the edge of the circle, and the measure of this piece right here, so this is the arc, the measure of that arc right there is going to be exactly the same, as the angle itself. So since angle B is 84, that means this arc right here is also 84 degrees. So this says measure of arc AC. So the little swoop on top means it's an arc. So the measure of arc A to C is 84 degrees. This is called a minor arc because it is smaller than 90 degrees. And this one, the measure of angle ADC means you start at A, you go all the way to D, through D, and end at C. So it's the rest of the circle here. And to figure that out, to figure out this little larger arc, you would say, well, the whole thing is 360. If you've used up 84 of the 360 to figure out what's here, I would do 360 and I would subtract the 84. And so my answer is going to be 276 degrees. And that's how you find the angles that are at the center. Should be the same measure as the arc measures as well. So we're not going to do all these examples, but let's do a little bit of practice with finding the angles and the arc measures. So in number 1, we see that this angle JNK right here, this piece is 21 degrees. Now I'm going to mark everything I know in the picture first, and then I'll come over here and answer the questions. I see that these two angles right here are directly across from each other and they make an X. So these are vertical angles. And I know that vertical angles are congruent. So since this angle right here is 21 degrees, that means this angle directly across from it is also 21 degrees. Now, I know that these are angles that come to the center. So since the central angle right here is 21 degrees, that means the arc measure directly in front of it, so arc JK is also 21 degrees, which means this arc right here is also 21 degrees. Okay, so these are the radius or the radii that make up the circle. Now, I do also see that there's a line from J to L, right? And this goes all the way through the center of the circle, and this is half of the circle. This piece from J to L is called the diameter, and it essentially takes my circle and like puts it in half. So I know that right here, half of a circle is a straight line right here. It should be 180 degrees, right? Because 180 plus 180 will give me 360. So if I'm looking at like just this piece here, if you know that you've already used up 21 of the 180, what you can do to figure out this leftover piece right here from K to L is you can take 180 and subtract the 21. And if I do that, I'm going to get 159. So I already know that this arc is 159. That means this angle right here is 159 as well. And again, these are vertical angles, so whatever's happening over here is the same over here. This one's also 159, and the degree of the arc J to M is also 159. So now using all that information, I'm going to plug in over here. So the measure of arc JK from J to K right here on the exterior, the outside, this is 21 degrees. The measure of angle JNM is here, JNM. So it's this piece between the two. That angle is 159 degrees, and that's when we subtract it. The measure of arc KL from K to L, again, should be the same as the opposite side, so it's also 159 degrees. Okay, the measure of angle JKM means you start at J, you go through K, and you end at M. So you have to go essentially like all the way around the circle. So it's J through K, ending at M. So it's like this whole section. So what I'm going to do to figure that out is I'm just going to add the pieces together. I'm going to add JK plus KL plus LM. So that is 21 plus 159 plus 21. And if I add those together, I get 201 degrees. Last one is the measure of arc MKL. So MKL means you start at M, you go through K, and you end at L. So it's essentially almost the full circle, except it does not include this little piece right here. So what I could do is I could add 159 plus 21 plus 159, or I can take the whole thing and subtract the piece that's not in it, which is the 21. They'll both give me the same answer. So I'll do 360 minus 21 just because it's a little faster, and my answer is 339 degrees. There we go. All right, I'm just going to do one more. I'm going to do number 3, and then we'll go to the last section. Okay, number 3. So again, I think it's easier to mark everything in the picture first and then to go back and actually like answer the questions. So I see that this right here is 90 degrees, which means that this arc from C to D is also 90 degrees. I know that this from C to E is a diameter, which means this is 180 degrees. And I know if I've already used up 90 of the 180, then that means this one over here also has to be 90 degrees and 90 degrees. Both of these. So that's easy, which also means, right, here's another diameter from G to D. That means these two have to add up to be 180. So again, I've got another diameter. So this piece is also 90. And I know in total, these two pieces are also going to have to add up to be 90 degrees because the whole thing has to be 360. So what I can do is I can say, okay, I already know that this piece here is 34. I know if I add this plus this, I have to get to another 90 degrees. So I'm just going to subtract the two numbers. So 90 minus the 34, and I get 56 degrees. So this is 56, this arc, which means this angle right here is 56. And then this piece is 34, this arc, which means this angle is also 34. And all together, if I add everything up, I get 360. So now we can kind of go in and answer these questions. The measure of arc CD, C to D, is 90 degrees. The measure of arc FD, so from F to D, ignore this piece, F to D means the 34 plus the 90. Okay, which gives me 124 degrees. The measure of arc DCF, so this is a major arc, so I know it's going to be more than 180. So DCF means you start at D, you go through C, you end at F. So I'm going to just add those pieces together. So D to C is 90. C to G is another 90. And then G to F is 56. Ooh, sorry, I ran out of room there. Add those all together, I get 180 plus 56, so 236 degrees. And then the last one, GDF. G, you go through D, you end at F. So GDF, as you start here, you go through D, you end at F. So it's essentially the whole triangle except for this 56. So I can either add them all together or I can just take 360 and subtract the 56. And my answer is 304 degrees. All right, so you guys can try 2 and 4 on your own. And then we'll flip to the back and then we'll be finished. So on the back, it is something called an inscribed angle. So notice how this picture already looks different than the ones on the front. Central angles mean the angle comes literally to the center, right? Inscribed angle is an angle with its vertex on the circle. So it's not in the center, it's on the circle. And the two sides are something called chords. So if I look here at this picture, the inscribed angle is this angle here, angle ABC, because the vertex where the 2 points come together, two endpoints come together, is at point B. B is on the circle. And then this side from A to B, this is called a chord. And this side from B to C is also called a chord. It is not a radius because it doesn't go to the center. You have to go to the center to be a radius or to be a diameter. It has to go through the center. Oh, sorry, my lights turned off. Okay, so that is an inscribed angle right here. Okay, so my inscribed angle is angle ABC. An intercepted arc is the arc that lies between the endpoints of an inscribed angle. So this piece right here, that's the inscribed angle. This part from A to C that goes from those two endpoints, this purple part is called the intercepted arc. Right, so arc is on the edge of the circle, and the angle right here is right in this center piece. That's the angle there. So you got the inscribed angle and the intercepted arcs. The degree of the inscribed angle is equal to half of the measure of its intercepted arc. So here's what that means. If this arc measure right here was 100 degrees, then this inscribed angle right here would be half of it. So my inscribed angle would be 50 degrees. So to figure out this angle measure, you have to take the arc and you have to divide it by 2, right? Take half of it. And vice versa, you go the opposite way. If I gave you 50, you would double it to get this answer out here. Intercepting a diameter. So if an inscribed angle intercepts its diameter, so if you see a line that goes through the center, then it creates a right triangle. So angle BAC, this piece here, that's the inscribed angle. This is a 90-degree angle, and this should make a nice right triangle. So that angle measure is 90 degrees. All right, so let's do a couple examples here. Find each angle or arc measure. So this says 88. I'm sorry, I know it's hard to see. This is the inscribed angle, and I want to find the arc measure of JML. So I want to find this piece. So I take the angle and I just multiply the angle times 2, and that will give me the arc. So 88 times 2 is 176 degrees. So this from JM to L is 176 degrees. Next one. This time I give you that the arc is 34 degrees. So to figure out angle ABC, this small one right here, to go the opposite way, I'm going to take the arc and I'm going to divide it by 2. So if I take half of it, I get 17 degrees. Easy peasy. Oops, sorry. Okay, next one. Now, this one's a little different because you don't have the angle and you don't have the arc. So that makes this a hard problem to try to figure out what this angle right here is if I don't have anything. However, here's what I do know. I know that this arc from X to W is 86, and I know that this arc from X to Y is 156. I know in total a circle is 360 degrees. So what I'm going to do is I'm going to take those two pieces and subtract them from the 360, and that will give me this arc right over here from W to Y. So I'll take 360 and I'll subtract the 86 and 156 from it. So if I do that, I get 118 degrees. So this arc is 118 degrees. And then to figure out the angle measure, I need to take that 118 degrees and I need to divide it by 2. And when I do that, I get 59 degrees. So this angle right here is 59 degrees. So sometimes you kind of have to use like a little bit of the other information to help you out. Okay, next one. Here's my angle. It's 42. So to figure out this arc right here, this is intercepted, so I'm going to take the 42 and I'm going to double it. And that gives me 84 degrees. So this piece is 84 degrees. I'm trying to find arc RS. This is what I'm trying to find. Now, I know that this piece right here is 84. I'm trying to find this piece over here. I do also know that this piece of the circle down below, Arc TS, is 171. So to figure out the piece that's in green, I'm going to do just like I did for the last problem. I'm going to take the whole circle, which is 360, and I'm going to subtract the two pieces that I know, which are the 84 and the 171. And so when I do that, I get 105 degrees. Okay, last two questions are actually two questions that are straight from the spring break challenge. So if you're watching this, you've lucked out because I'm going to essentially give you the answer to two of the questions on the spring break challenge, which is cool. All right. So this is spring break challenge question 3. So it says circle O is shown. Chords A, B, and C, D intersect at point E. So what I see here are some angle measures, right? So I've got some, this is an angle, this is an angle. Now notice that here's like one of my angles, right? From B, A to D. Here's the angle is 33. I notice that it's coming to the edge of the circle. It's on the circle, which means it's an inscribed angle. So to figure out this arc right here, I'm going to take my angle and I'm going to double it. So 33 times 2 gives me 66 degrees. So arc BD is 66 degrees, which is one of the questions that it asks me for, one of the arc measures. The second angle I see here is CDA. And I see again, this is an inscribed angle. This angle right here is 27. So to figure out this piece, the arc for CA, I'm going to take the 27 and I'm going to multiply it times 2. And then that's going to give me 54 degrees. So that's arc AC. The last arc it asks me to find is CB, which is right here. Right, that's what I'm trying to find. But you'll notice AD goes through the center of the circle. So this is half of a circle, which means this should add up to be 180 degrees. So to figure out what's left over, I'm going to take 180 and I'm going to subtract the two pieces that I know, and I'll be left with my final answer. So I'm going to do 180 minus 54 plus 66. And if you do that, you get 60 degrees. So there's your answer for question number 3 of the spring break challenge that you get to through Performance Matters. All right, last question. This is question number 4 on the spring break challenge. So what I'm seeing here is it says in circle M, A, B, and BC are chords. A, B, B, C, these are chords. They intercept the diameter right here. So because of that, this triangle is a right triangle. So angle B is 90 degrees. I'm also told that angle ACB is 30 right here. Now, I see angle C is 30, and I see that it comes to the edge of the circle here, which means that this is an inscribed angle. So because I know that, I say, okay, if this is 30, then I can figure out arc AB right here by taking that number and doubling it. So 30 times 2 gives me that arc AB is 60 degrees. Now, you will also notice here that this is a triangle, right? Triangle ABC. And you know that in triangle ABC, you already have a 90 degrees and you have a 30 degrees. So I could figure out what angle A is right here if I decide to add these two together and subtract them from 180. So to find angle A, I'm going to do 180 minus 90 plus 30. 128, 6. So angle A is 60 degrees. So I'm going to put that in here. This is 60. Now, here's the cool part. There's another set of inscribed angles, which then make an intercepted arc. So this 60 degrees right here, it's kind of hard to see, but notice that this now opens here. It opens up to arc BC. So I could figure out arc BC by taking this 60 and doubling it. Or I also could have said, hey, since this is a diameter, if you know that this is 60, this whole thing should be 180, I could just subtract them from 180, and that would give me what's left over as well. But I just double 160, I get that this is 120 degrees. Now, oh my gosh, here's something else. Angle M right here, if you look like this, right, here's angle M. Notice that this angle right here is at the center. So it opens up from the center to this arc BC, which is 120 degrees. Now remember, central angles are exactly the same. They're equal to their arc measure. So because I know that this angle M opens up right here to arc BC is 120, that means this angle right here is also 120. And so because that's 120, I now have another triangle in this picture. Oh my gosh, here's the other triangle, MBC. And I could figure out this little piece of angle B because I've got the 120 and 30. So I'll subtract it from 180 and that'll give me what's left over for this little piece in here. So 180 minus 120 plus 30. So 50. So this is 30 degrees. So this angle right here is also 30 degrees. And then I can figure out this angle because I know that these two added together have to give me 90. And if this is 30, 90 minus 30 gives me 60. And then, oh my God, I've got another triangle here that has to add up to be 180. So I can do 60, 60. This one also has to be 60 to add up to be 180. Oh my gosh, that was a lot. But now that we have everything marked, we can answer the question because the answer to the question says, select all of the statements that are true. So first question says, triangle BMC is isosceles. BMC, my one in pink here. Isosceles means two of the angles are the same. And yes, it looks like two of my angles are the same. So that is a true statement. Number two, the measure of angle BMC is 100 degrees. BMC. That angle is 120. This one says 100. That's false. Letter C says the measure of arc AB is 15 degrees. So A to B on the outside is 60. So this is also a false statement. Letter D, triangle ABC is a right triangle. ABC. Heck yes, it is. So that's correct. The measure of arc BC is 120 degrees. So from B to C, yep, that's what we got, 120. So that's also true. And triangle ABM, so this little guy up here, the 60, 60, 60 triangle, is a scalene triangle. Well, scalene means none of the angles or sides are the same. This is an equilateral triangle because all of these are the exact same angle measure, so everything about it should be the same. So this is not a scalene triangle. That's false. Woo, a lot of work. Okay, so now we've done your notes for central and inscribed angles. So you're now going to go on to Canvas, and on Canvas you will find a extra credit. It's like a quiz or a Quizlet underneath modules, and you will take that little test on Canvas for extra credit. You can take it twice. I'll take the higher grade. Use this on it. It will help you tremendously. The questions look exactly the same as these, all central or inscribed angles. Hopefully this was helpful, and you get a little sneak peek of what's to come next chapter. So hope the video was helpful. Have a lovely weekend, my gems, because it is Friday and I'm making this video for you. So love you all. Have a good day, and I'll speak with you soon. Okay, bye.